Welcome. In this video I'm going to show you how you can determine the measure of consensus using Python and doing it the hard way. There are no libraries except my own. I have a separate video on how you can do this with my own library, but in this video I'll just go over the formula. I'm using Jupyter Notebook with Python 3.8.18. This measure can be used as a measure of dispersion for ordinal data, and it was developed by Tesley and Bierman. To show you how it actually works, I'll need some example data, so I'm gonna install pandas and import it. So I can use the read CSV function from that library. I'm using the General Social Survey from 2012, the A's, because I slightly adapted it, changed a few small things. It's just for an example. I don't need all the data, I just need one ordinal field, so I've chosen how scientific is accounting. So I'm going to store that as my ord field. And to quickly see the get a quick impression of this data, the frequency table using the values counts, you can see that 100 people thought was very scientific. Note that these are not in order. To see the unique values, you can use the field of interest and then unique. And it might be useful to actually store these as a dictionary, which I've done over here. Now, in order to make this fully done without any libraries, I first convert this now back to a list. Remove any missing values, so I can do that like this. That should remove any of the non-values, and it will only work with numeric data, so I'm going to replace everything from my coding, and that's going to be then in X. So just to show you that that has now really happened. Oh, I didn't run my coding, so now it should work. So now I just have numbers going from, well, it's quite a lot actually, going from 4 to 1. Alright, that brings me to the next part, the formula, which looks perhaps a bit scary for some, but it's not too bad. What we're going to do is we need the unique scores and how often each of those occurred. So that values count, but we're not using libraries from other than from Python. Now luckily Python has in its collections library the function counter, so we can use that. And that will actually count the frequencies from a list. Although we want that list then to be sorted based on the keys. Otherwise we get different wrong sorting. And then we can actually get the frequencies by just doing this, and that should give me again the frequencies. So now I have them without using pandas or anything else. It might be useful to have the number of categories and the total sum, so that's my k and n. And then the next part is the proportions. So this is simply to take the frequency divided by n, not the p divided by n, it's the frequency divided by n. So we can simply do I over n for every frequency, and those are my p-values. Then this mu is actually, you multiply each category's frequency by its rank, which is simply the index. However, and then divide by n. So we can do that by simply doing I, but make it go from 1 to k plus 1, because ranges are excluding the last one. And if you don't specify a starting value, it will start with 0, so we need to adjust that. Indexing of arrays and lists in Python start at 0, so we subtract 1, so the first one, 1 minus 1 will become index 0. And this gives us our average rank. Last we need is the maximum range of the ranks. So, well, since we only have 4 categories, the highest value would be 4, the smallest would be 1, so we can simply do the number of categories minus 1. Last thing we need is the log2 function, which is luckily available in the math library that comes with Python, so we can still use that. We import it, and then we can fill out everything in this formula. It starts with the 1 plus, so that's over here. Then there's a big sigma sign, which is actually a sum of the proportion, so that's that one, multiplied by the log2, so that's that function we're importing. 1 minus, 1 minus, and then these vertical stripes indicate an absolute value. So if it's negative it becomes positive, and if it's positive it remains positive. And then it's I, and I need to add 1 because I'm doing the range from 0 to but excluding k, so I'm adding 1 here, and then subtract the average that we calculated earlier divided by the main range, and that should give us finally that consensus value. Alright, I hope this video was helpful, and thank you for watching.